Hello there. Today we'll be doing longest substring without repeating characters. So in this problem, we are given an input of string, and we want to find out what the longest substring without any repeating characters. So let's look at this example and try to understand it. So in this example, we have an output of 3. As you can see, there is A, B, and C. So if we have a substring that is 1, 2, 3, we see an A. That means we have to remove an A from the last item, and then we can keep moving on. So then we see a B, then we remove this B, and we can add this B in. Then we see a C. If we see a C, we have to remove a C from the last item and then add it in. If we see a B, that means we have to remove A and B before we are able to move on. And we have CB now, and we have 1B. That means we have to remove 2 items before we can get a single item called B. And some might think that this is a sliding window problem. And yes, it's somewhat like a sliding window problem, but a sliding window would result in a runtime of O of n squared because we have to check the entirety of this window for the next item, like let's say A. So let's say we have a left to right item, right window, and we look at the next item and we see A. We have to look through the entire sliding window sometimes to check for that one item. A way to avoid that is to use a set. If we use a set and sacrifice time for space, space for time, we can do this in O of n because we're using a set. We can hold these items in and use, and then we can remove it immediately and move on to the next item while that item's inside our set. So with that example, we can basically choose to use a set to hold the items. And here we have the same situation here. If we use that set holding item idea, then we can hold 1B at a time until the end, and our output would be 1. And we have here the last example. Some edge cases that we might want to consider is a string of 0 characters, as this is possible. So what 0 characters, let's say inputs of 0 characters, what should output a 0 because the set has not taken in any single character because there are no characters to add. Okay, so that's the edge case. With that, I think we're ready to get going with the method. The method is to use a set to hold unique values and also a pointer, or yes, a pointer to move through the string. Okay, let's have a plan. So a plan is to, for each character, add to sets, and upon seeing a unique character, remove that in a duplicate character, sorry. Remove that character from sets and then add to set. Check the max length of the set of characters. Set of unique characters. Alright, with that, those are 2 items that we need to hit, and let's implement it. So for C in S, we need a max length, and we need a set. we'll call it scene, and we need a max length equals 0. So while C in scene dot remove. I see. We do need a pointer. So left pointer. Let's set that as 0. Left pointer of the string, as you can see. And so remove the left pointer. And once that has been removed, we can add this back into scene. With that, we can check the max length. Between the current set, the length of the current set, and the previous max length. And we take the longer of the two. With that, we can return the max length, and we should be good to go. Let's go through some examples with our review. We're in about 6 minutes right now, so here are 3 examples. So I think that goes pretty deep. Let's move down. Okay, here we go. So let's have a left pointer, as we suggested earlier. We have a scene, we have a character, we have a scene is equal to a set, and we have a max length, and our expected output is 3. So here we are. We have C. There's nothing inside scene, so we just put A in. Then we move C to the next item. We see B. Then we put B in. Then we see C. Then we put C in. Then we see A. That means we have to remove items from the left pointer until the end. So until we've removed A. So we move it once, so we removed A immediately, and this A is no longer in scene. So now we can add the next item in, which is A. And this kind of repeats, and we as we move C and we find B, so we remove B, and we move L, and we move C again. We move C again, and that means we have now C in this lineup, and we have to remove C, and so on and so forth, and we add it back in. As we move it forward, we have another B. So at this point, we have seen a max length of 3, as you can see, and that's the update. And now we have a B. Once we see a B, we have to remove these 2 items because we moved the L forward twice before we can remove it. And now we have CB. Of course, this length is shorter than our max length, so it doesn't get updated, and we get another B, and so we have to remove the 2 B's until we can get CB until we can add B in, and that's the max length 1. So that's that doesn't get replaced, and now C is done, and we are ready to return, which is 3. Perfect. And the same thing for empty array. That's the edge case. Let's check that out. So edge case. So for C in empty string, there's nothing occurs, so we return a max length of 0. Perfect. With that, we're done with our review, and I think we can do evaluation. Evaluation is that we can have a total possibility of a couple hundred unique characters. So, but we will also have to go through an entire string to find the longest string. A way we can offset that is create a limitation on how long our string can possibly be, is to find the unique numbers of letters, digits, symbols, and spaces possible. and that would allow us to say that it is a O of 1 operation because it is bound by the unique number of letters, digits, symbols, and spaces. And once we hit that maximum length, we can return that maximum length because it does not get longer than that. However, we cannot return O of 1 because, well, we may never get to the max length, and we would have to go through the entirety of the string to make sure that it can be done, or a new max length can be done. So with that, we will have to run it at O of n. Even though, I mean, there's some optimizations that we can do to make that possible, but it's not necessary here. So here we have an O of 1 space because we know for sure it's bound by the number of characters, digits, and symbols and spaces available to our scene set. So O of n time and O of 1 space. Let's run the code as we comment everything else out and move the implementation up till this particular point so that everything can be seen clearly. And let's run the code. So let's submit. All right, we have solved it. If you have any questions, please comment below. If you enjoyed the video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.